It's like these futuristic things, right? Where you had like bionic arms and all that. And then I was looking at like the brain augmentations to see like how science fiction has evolved. And all these things were originally written sort of pre-internet. So the closest thing to like something where you could like plug your brain into the internet was a device that like you could put a physical jack, so no wireless either, no Wi-Fi. You could put a physical jack from like your brain into devices like CD players and VCRs and things like this. So that was funny just to like go back, like, oh man, in 2015, like it'd just be like we were just wirelessly uploaded to the internet. That's what the future looks like now. But it's funny how the future keeps
Basically, the only problem that we solved was the problem that they didn't, which is removing the cable.
Yeah. Well, and then the whole like network, because it was like, yeah, what is the most appealing thing that you'd want to be able to plug into? It was like, well, I'd like to be able to like read my email or in a Google search.
Fast forward the CD player with your mind.
Yeah. Okay, so let's go ahead and get started. Thanks, guys, for joining. I've pasted the link for the agenda. Let's have a look. Sort of try to put together updates for folks. So I also wanted to update folks on the teams. I guess we'll get some of that going in there. Yeah. Okay. I'll provide. So we're working on progress reports. We've got some different levels of finality. So thank you to Geppetto. Thank you to the Geppetto team with Matteo and the Move Validation team with Jim and Michael for submitting some of those, and I will talk through some of those for new teams like the Muscle Neuron team and the Pi OpenWorm team, which are really just new teams as of like this month or last month. But okay, let's start at the top with news. So wow, in the last month, there's been a ton of media. And it just can't not say something about it here. Although larger implications and ramifications and intrigue and all those sorts of topics, I'm sure we can get into in a different setting. But the large effect is that there's been postings on major media sources. There have been quotes related to microscopy that I've been a part of. There's been a rather prominent CNN article that launched 1,000 tweets. As far as I could tell, I literally could not keep up with everybody retweeting about the project. So the project is in the public eye again, and obviously folks are taking materials from the project and using them and posting about them and producing interesting applications of them. And who knows where this will all go. We are getting lots of inquiries, from folks around the world interested in the project and talking about its significance. As far as I'm concerned, the mission of the project is still, is still to be an open science project and to provide resources and make them available to folks. That's centered on creating the first digital organism, and that's the same message that I'm sticking to. In regards to applications, the most prominent one, of course, being this robot. But other applications that may come, I think, are all sort of in the same camp of everybody's free and welcome to build interesting applications, and they're also free and welcome to talk about them, and they're free and welcome to post about them and create awesome things about it. And to the extent that that feeds back into the project, that's terrific. To the extent that folks want to go and do their own things with them, that's cool too. I think that's generally the way that this has all worked for everybody. So for me, it's just an opportunity to remind myself and all of us that the project is exciting and ambitious. The other aspect, of course, though, is that we always want to breed more caution into the media than they're likely to take upon themselves. So the media game of telephone seems to only amplify the amazement of our accomplishments. Well beyond anything that I would say in terms of humility. So I have experienced even some creative editing or creative, interesting final products of what comes out in stories compared to what I've said. So to be clear and be on the record, I don't go out asking anybody to interview me. It's more that people come and they email us and they say, we'd like to talk about blah, and then I'm there to talk about it. So I am in no way seeking this media, but I have to try and answer for it. And so that's the first thing. And the second thing is that I'm always trying to communicate that what we're aiming for are peer-reviewed, peer-reviewed applications, that we're based on a serious science approach, and that the core of the project puts everything that they do out in the open. So anything that is not out in the open is not part of the core project. So that is, we rally on GitHub, we put our docs up on documentation. So that is the main thrust of the way and the style and the manner in which I'm attempting to respond to this flurry of things. As always, if you see anything and you are not comfortable with it, please reach out, let me know. These days I'm I'm just doing my best to keep up, essentially, and I'm doing my best to communicate the best pace of the project possible to everybody who asks me about it. It usually never comes out exactly the way that I would have hoped. Almost never do I see an article that hits it spot on, but nonetheless, my hope is that in the places where a journalist exaggerates in order to make it a bigger headline, that it doesn't turn a scientist off, but instead it excites a creative young mind, a teenager or a college student or someone thinking about how they want to take their career, and to think about what's possible, and to think about the good that we can do with this is my general hope. Always, it's a fine line to try and walk that balance, and like I said, I'm never 100% happy usually with anything that comes out, but I'm just trying to be as transparent, as honest, as clear, true to the mission that I think we've all been a part of. But again, if you ever see messages coming out that you have an issue with or disagree with, please just drop me a line. I really don't want to upset anyone. It's you can't live life never upsetting anybody, but I'd really like to not upset anybody. To the extent that's possible, just keep in a communication with me. Does anybody want to say anything about that? I'm sure if you've got any kind of a feed or a search or anything on OpenWorm, you've seen what I've been talking about in this past month. You want to say anything?
Yeah, no, there's been definitely a lot of publicity, and it is around the automatically said that yes, this is done by the OpenWorm project, by the people in OpenWorm, which is partially true, but yeah, they've not made the specific connection that it's not necessarily one of the current core features of the OpenWorm project. I think it's probably the best thing we can do is maybe, obviously, it's great that you're there communicating and answering anybody who has any specific questions, and hopefully people will pick up the specifics, but it's probably also important to make sure that any of the documentation on the website, any of the frequently asked questions is as up to date as possible. Because I don't know especially the main website, maybe it's not been updated in a while in terms of current activities and so on. Definitely, for example, Mike Vella's optimization stuff has definitely had been one of the core things, and it's probably a slightly smaller part of other things now at the moment. So I think maybe we need to refocus on what the maybe 5 or 6 core projects are at the moment, and then just have a summary of these on the main website. One other thought that sprung to mind, I don't know whether it's a good idea or not, was to actually have a blog post or have a page which gives some links to Popular Science or even CNN or New York Times or whoever, good articles which have been written about OpenWorm, which are fair, balanced, and reflect current thoughts, and completely wacky articles. I'm sure there's a lot in between, but we can actually say there that some of them, well, actually these, and okay, if they are completely inaccurate, some of the things that they've been saying, then we can actually point to them. But some place to show people, okay, a lot has been written about the project, some are better than others, and just to be clear about this, so that if somebody comes along and says, well, this article was slightly inaccurate, we can just point them at something saying, well, okay, this is the range of things that have been written about OpenWorm.
Yeah, we haven't updated this in a while, but there is this, and maybe better. But these are things that we put up that we thought were good. This is probably still 1 or 2 news cycles ago since we pointed this stuff on here. But
you could add the Economist article there just to mention one. I thought that was a pretty good one.
There's
back
quite
from
a
May.
few. Yeah. There's quite a few that are missing there.
Quite a few there.
That's true. I'll also point out that at least one of the articles on the BBC, for example, got the project leader wrong. It was John Landis? John Hurleman. They spoke to John Hurleman. He put a blog post someplace, and somebody at the BBC identified him as project leader of.
Yeah, I know that was even 1 news cycle ago. But yes, okay.
Yep.
So this is good feedback. So what I'm putting here is
I don't know in general. I mean, I'm personally conflicted daily. One of the major things is that the language of the media is not the language of science. And to be honest, I don't work in the media. I don't know how to approach any of this, but definitely whenever I read the phrase "mind of a worm," regardless of what's around it, it's like it doesn't feel appropriate in any way. But I don't know if how we should approach that. It's like, shall we discourage? We should. I mean, should we say, okay, first define mind and then we talk again? I mean, how do we want to push? How far do we want to push it? And how far do we just take to our internal verbiage that we can control?
Yeah, I think we can only control what we can control, unfortunately, and nobody ever runs a headline by me and says, "Hey, what do you think? Is this going to be accurate?" So they never ask. So all we can do is try to correct. There have been a couple of cases where there's been an error or two that has just been so egregiously factually incorrect that I've actually mailed. But it does take effort, and it's not always going to change. But I did do that with, I think, a New Scientist article a few months back. There are, and I mean, right now there's a big discussion going on Reddit, for example. So one thing we can do is to be present, is to make sure that there is representation of those of us who do things like go on to and make comments on things on big forums like Reddit, and just like be present and be there to set things straight. Unfortunately, if it all comes from me and it's just like Stephen Larson like typing all these things, and it starts, I think, getting a little bit insane. So the more help that you guys can make on these things, like I think the technology forum right now has a big thing about it. Do you
have a link to that Reddit?
Yeah, I can dig it up here. There's a few of them. There's one. Well, you know how Reddit is. It's like Reddit will will post something, and some of them will get very big, and others of them will sort of not get very big. But there's one with like 900 comments or something. I'm looking for it. That's probably the one. That's the one I mean more specifically. If you go to our technology and you search for OpenWorm, they're posting to one of the many things that have come out. Let's see. I was just looking at this yesterday.
And then you did an AMA there at one point, so it'd be nice if somebody linked to that in there. Maybe I should, okay. So
I did, and you saw on the mailing list that people are calling for another one, which would be maybe a good idea. Okay, yeah. Sorry, I'm not seeing it right now. I will find it though. Did you find it? Okay. But you posted a specific comment. Okay. Anyway. Okay. Any other new ideas or thoughts on the media? So updating the page. Just trying to. Yeah. Well, we can control. I think the FAQs are good. We could probably have some pointed FAQs of like, have you reproduced the mind of the worm, or just like things to try and like clarify at least there, and then those become easily linkable things that we can point other people to. Might be a nice. There might be like what is it? Mythbusters. A Mythbusters section of our.
Or even, would it be useful to have a blog post specifically on the recent discussions?
Might be. If folks feel comfortable about that, we could do a collaborative editing round on on that. I mean, we could do both. I mean, we could do that. We could make one that's specific for like right now, for the present moment, and we could do FAQ updates. So let me put that as a list as an option as well. So
another not mutually exclusive idea to what we said so far would be maybe in relation to the robot, explicitly maybe having a page on the site that lists applications of OpenWorm technology. So people that have used OpenWorm open source software and the stuff that we built and applied it somewhere, and this could be one of them. We could say, look, here's what's been done. We have this robot that someone's done. Maybe some other things that are to make it very explicit that we're not upset this has happened. We're very happy that people are doing things with the OpenWorm stuff, and that it also helps to make it very clear that it's not part of the core effort that we're working on.
Yeah.
Just
so
an
actually,
idea.
so with regards to that, there is this page on the docs, which was last updated way before any media attention came to. This was a year old. Probably, but you can see on there that there's a reference to some of those things like that. The intention of this
yes,
is related to what you're saying there. It's in the docs.
You have it there, yeah.
Yeah, it's in the docs. It's not on the main website. But yeah, that was the idea of that page. But yeah, it's not prominent. It's not very prominent, obviously, since we don't know about it very much. So yeah, the thing about keeping the website up to date and thinking about what focus we want to place on different things is something that requires some thought. But I think it is worth iterating on now.
This seems kind of reminiscent. Last February, I went to Washington D.C. and this government program, IARPA, had they got together a bunch of neurobiologists and a bunch of AI people together in the room, and it was kind of like, I think the biologist said, well, those people really aren't doing science at all, which they're not, So, so they kind of looked down their noses at them a little bit, and there's got to be room. There's got to be a place in the room for both these people, So, we're doing really, hard biological science. That's the goal of most of the projects here. But there's projects that are like the robot, that are. The thing is, so we don't know where the holy grail, or if many of them are. There's got to be room for approaches from many directions. So
yeah,
I mean, like the project I did, which is like using a genetic algorithm to train the whole thing, the whole connectome. It was a lot of fun, and I got a paper in, actually. I'm trying to get it published.
Okay, great.
In neurocomputing. Maybe has a 50-50 chance. I don't know. We'll see. I think it's valuable. It's fun, and but it isn't hardcore biology, but it's still good stuff, right? I don't know.
Yeah.
I'm kind of ending up weekly here. Okay.
No, definitely. No, I completely agree, and I want to distinguish between the work and the way the work is being reported.
Oh, yeah. Well, you made a very good point on that. I understand. Some of those things, I've read those things, and they're just kind of way out there.
Right. So I think the work is valuable. I think that, and I completely agree. I also think that OpenWorm's purpose is to be an intersection between those different efforts. In fact, the things that are very biologically driven, and the things that more come from the AI perspective. I personally embody those two backgrounds. So I mean, I did a master's that was purely driven in AI before I basically learned any biology at all. So I am also of that world. So I think that those two things intersect, and we're to some extent trying to level that up, because we also want to make sure that we do make predictive models. But yeah, I think that there's certainly room for all these things, and I want to encourage all these things to continue to happen. We also want to be sure that we're and I also think you can do science in AI, but you have to do things like peer review. And if you want to be doing open science, then you need to be making your methods available to everybody, so everybody can check it out. And we can all kind of that's the real thing about science, is just transparency and letting everybody know what you've done, so that we can all investigate it and build on. But I completely agree. I'm really glad that you said that. Okay, just in the interest of time, I think let's move on past the media stuff and let's keep talking about it. I think we've got some good suggestions. I just wanted to let folks know, and I will link in the agenda here. I've given a couple talks on the project that were invited. One was at a Science in 3D festival with a specific part of the NIH, not the whole NIH. Sounds more impressive than it really is, but it's like the NAIAH. Anyway, they were having a Science in 3D festival, and they wanted to hear about the 3D parts of OpenWorm, and so I talked about it, and that got streamed and got some tweets. There's all the presentations I do, by the way, are in the Google Drive under Presentations folder, and so there's a couple of Google Slides presentations that are there. You can check those out. Thank you. I think it's Michael Lincoln. I appreciate it. And the other one is I gave it Janelia Research Campus. This one got a little bit more hardcore because there were actual like computational neuroscience modelers, and I got some pushbacks or just good questions, so basically about like the enterprise of doing ion channel modeling and you know, if it will succeed. And I got some good suggestions actually about some things that we should be thinking about more, which kind of cross-cuts the project, which is if you take the movement of the worm that we're seeing in these movies, how much does it constrain the activity of each individual muscle that adds up to that movement? Meaning, like, if we get our statistical model of the movement, what's the statistical model of the individual muscles, given that they have to produce that movement? If that's a strong constraint, I was hearing this feedback. If that's a strong constraint, then our modeling enterprise is buffeted along. It helps us a lot because that means that the movement constrains the muscles, and the muscles constrain the neurons, and then we have some ability to fill in gaps better. Whereas if there's like millions of different ways to get the same set of behaviors, you know, millions of different combinations of muscles that add up to exactly the same behaviors, then it's a lot harder because the problem is much less constrained. I got a pretty pointed question like, do you know how constrained it is? And I was like, no, actually, we haven't really done that. We don't really know how constrained it is. But the point is that is actually something that no one's really asked. Maybe Nina Cohen has asked it, but I don't know if she's not published on it. So it's a worthy scientific endeavor, and it's not really, we don't really have a focus to even try and answer that question. So I thought it was valuable in that way to get some more exposure and let more people know about it. About 10 or 15% of the people in the room had heard of the project, so now it's more. Yeah.
So who was your host then?
Jeremy Freeman.
Okay.
He does big, sort of more big data analysis, but it's web-based stuff. And one of the newer, I guess, faculty of the project. So anyway, so I was very grateful to be invited both, and you know, got the word out, got some more feedback, sharing it with you guys. You know, all those folks now become contacts for us to talk to, and if there's any communications, my goal is to be a conduit to talk with any of these folks. So please take me up on that if you have ideas. Okay, and then, and I need to stop talking, so let's get through this. So we also, in this last month, had a journal club. I presented on this neuromuscular synapse. That's out on YouTube. Maybe somebody can dig up the link for that too. But we talked about this paper that got us into more depth on how the muscle cell reacts to different stimulation, both direct stimulation with optogenetic channels and also through synapses. Where the neurons are stimulated with optogenetics or electrically stimulated. And the direct consequence of this for the muscle neuron team is that we can basically digitize the graphs in this paper, turn them into unit tests, which become constraints for our simulation of the muscle cell. And so there's now a few issues that have come out of that, that journal club in the muscle model issue list, which is trying to be just the first simple thing, which is just to digitize a figure and turn it into a unit test that we will likely fail, but of one muscle cell, so that we can just see like how close or far are we from that. And it just defines like how much input does it need to get, what's the trajectory of its current going to look like over time? How long is it going to last? That kind of stuff. So just stuff where we're turning data from papers into unit tests that get run on Travis CI. Oh, thank you. By the way, it was a nice talk. Yeah, so I think hopefully that will drive things in the muscle neuron team quite a bit. Okay, cool. And okay, lots of things are going on Gitter, in terms of the muscle neuron team. I'll give a little bit more update here below, but let's keep going. What's possible in 2015? Scaling up. So we still have more volunteers. Every time you see this media, you can expect that we're getting lots of folks that are signing up and wanting to talk about the project. I'm starting to shift my approach a little bit from real-time Hangouts to more interacting with people on chat. It's much more efficient, and it seems to still keep about the same retention rate in terms of people coming into the project. And so my first thing lately has just been to engage somebody on Google Chat, and then point them at some piece of the project, and then if they come back having experimented or played with something, it sort of indicates that they're maybe in and interested, and then I've been moving them into Gitter as much as possible as well, because it's kind of a much lower barrier, I think, than posting on OpenWorm Discuss. It's also targeted at a focus channel around a specific project, and there's not an imperative to immediately reply in real time, and folks can get back to it. So in terms of just helping out and building the community, if you can be on Gitter and you see folks talking and you want to get engaged with those questions, I think it's very good. I've been pleased to see more and more folks getting on there. It also helps because we can make this much more specific to issues, which I really like. The fact that you can just do hash and a number linked to an issue, something you can't do on the mailing list. It's very convenient to have these rapid-fire conversations about where things are with issues. So in terms of scaling up, I really am feeling like Gitter is going to help us do that. So I just want to tell everybody I think that experiment is going quite well, and want folks to let's keep on that. I still want to keep a big theme in terms of closing the Geppetto cybernetic movement validation C302 loop as a higher order thing. So we'll keep talking about that. Releasing WormSim. I think Joe can't join us today, but maybe we'll talk a little bit about it later. Okay, currently scientific teams, Geppetto, movement validation, neuron muscle are kind of what we're looking at in terms of coordinating. There's this loose team around PyOpenWorm, which I don't know I'm going to formalize yet, but there has been enough activity in there that seems like now there's a good synergy between PyOpenWorm and muscle neuron stuff. So I'll say a little bit more about that later. Okay, releases. So we got some progress reports and some ideas for the future. I don't want to go into them in too much detail now, but thank you, Michael and Jim, for putting together a document sort of talking about the past, present, and future of movement validation. Maybe some of that you can touch on in your sort of deeper dive today. Oh yeah, this stuff is sort of all not indented in the right way, is it? So we'll get that in there. Thank you as well to Matteo, who's been doing the same thing for Geppetto. I just think it's important for us to kind of log our work in the past several months. So folks got that in by today. My next step is going to be compositing that and compiling it into docs.openworm.org along with the other pieces and parts, and then also picking up all the things which are not officially under the project. That we're massing people under. But I'll re-summarize that for the next meeting. So thanks, guys, for that, and talk about the coordinated future plans. And Google Summer of Code 2015. Now what's going on with our agenda here? I don't know exactly. Okay. Google Summer of Code 2015. Folks still need our ideas in the ideas list. Some of those came through from the contents that Michael put forward. I think Matteo, we still need to have a conversation to think more about Geppetto, but you threw out some ideas informally to me. We should try to formalize those more. But yeah, INCF really wants us to give them ideas, and I think we'd really benefit from having more students. So I'm going to try to put more of an emphasis on that in the next few months. Okay. And so now, all right, does anybody want to say anything on that? I'll be quiet. Anything I've just done? Okay. Let's go on to movement validation. Michael, let's go to you. So we had allocated to do a deeper dive every month on some specific project. Michael volunteered for this time. Who's volunteering for next time?
I could say something on C302 and NeuroConstruct project.
Okay, good.
And try to link it in with the muscle model and neurons and everything else.
Okay, great. Well, Michael, so you are doing our first deep dive, so you're going to set the standard of what this looks like. Hopefully the idea is, obviously we're all familiar with the basics of these projects, so I think the idea of this is to get into some more details. So take it away.
Just before I begin, it looks like something terrible has happened to the structure of this agenda. I think the movement validation thing got copied and then pasted directly into the Stephen piece. I just moved it out. Anyway, nobody.
I'll try fixing it while I'm talking.
No, nobody worry about that, because I'm not going to talk to that. Okay, so let me just share my screen.
I'll try fixing it right.
And you guys see this right here?
Yes.
Yes? Okay, good. Okay, so I thought I would speak to the document that I created here with Jim, past, present, and future of movement validation. So forgive me, I mean, I know you guys have been hearing updates about this for the past year and a half, so obviously you're pretty familiar with some of the details here, but I don't know if I've sort of expressed the full extent of our vision for this at any one time, so here we go. So the idea here is ultimately for movement validation to be an open source package analyzing worm behavior that's used not only by OpenWorm but also by C. elegans researchers worldwide, which could potentially be a source of funding for the movement validation piece, and then potentially for OpenWorm itself if there's enough of a surplus. The service would be hosting the videos and the data and the processing of those videos in the cloud, and the data is would be stored in a relational database to enable all kinds of slicing and dicing of the data. And the feature calculation, statistics, and the computer vision steps, unlike the MATLAB package that we're adapting our work from, would each be loosely coupled, so that potentially different computer vision calculations, different statistics calculations could be swapped in relatively easily, rather than right now where everything tends to be more monolithic, and it would be more difficult to swap out the computer vision step because everything is sort of happening all at once. And also the ultimate vision is to have a web-based interface to support several use cases, like adding a film to the database of worm videos from a web interface, adding a feature, running statistical comparisons, or relatively simple ones anyway, and viewing time series plots of the feature data itself, as well as the worm's movement itself, viewing the raw video, overlaid with segmentation showing how it's been analyzed and segmented, and then most importantly, I suppose, downloading the results in various formats so that researchers could process it, probably using MATLAB, after they've queried the database for the worms that they're interested in and the features that they're interested in. And finally, most relevant for OpenWorm, the use case, of course, that we're focused on is to be able to pass in a video or contour file and then obtain a fitness function. So the idea is to implement this entirely in the Python SciPy stack, to have plotting with matplotlib, and obviously code hosted on GitHub, and the data, I guess I should say, not on Google Drive, on simple storage. And we're calculating things on an elastic Beanstalk instance. So that's the ultimate vision. So how close are we to this vision? Well, as as regular listeners to my updates, you know that we've translated the MATLAB code for features, for histograms, for statistics, and that was all done last year in the last half of the year. And after the OpenWorm conference, Chris Barnes had a good stab at trying to create a computer vision algorithm, because we chose to not try to convert the existing algorithm the Schaefer lab created, but rather try to create something else that might have fewer dropped frames. And so Chris Barnes had an attempt on that. Still a lot of work to be done there to make that ready for prime time, but certainly that's an accomplishment there that we made a pretty strong attempt there. And we've also forged a relationship with Andre Brown as our package's first customer. So in the new year, we're hoping to do quite a bit of work here. This is basically the full list of things that need to be done to achieve our vision. I won't go into every detail here. But basically, we want to align these all with issues, and so I'll be working on that the next little bit. So to do more of a deep dive and more of a show and tell into what we've done so far, I thought I would start by giving a preview of what Joe Bowen, a new contributor, has done with the vision for our cloud-hosted version of movement validation. So we have the movement validation Python package, which does the calculations, feature, statistics, but now this package needs to be run, and the idea is to run this on the cloud here. So here we have an elastic Beanstalk instance. This is pushed out from here. This is the GitHub repository that Joe Bowen started. And if we go back, so here there's, on the left here, there's the various use cases, some of which I was talking about. So if we want to create a new plate, which would be a video, go here. You're able to fill in this information, type in various information here, and then load this. You're also able to upload a video potentially. Select a video here. And then I don't have access to the S3, but here's a screenshot of Joe Bowen demonstrating his access to S3 here where the video has been uploaded. So here's the video right there. So we're well on our way here with this cloud implementation. We've also forward engineered a database schema onto this. So previously all the feature files, all the features were stored in files, HDF5 files. So everything was very hierarchical, and each wormed video was sitting in one feature file. Now the idea is to have this schema store all the data relationally. And this has been, as I say, forward engineered onto the Amazon RDS system connected to our elastic Beanstalk instance there. So that database can be populated. Right now it's empty, all the tables are empty, but in the future we'll connect this to the full Schaefer corpus, run all the feature calculations on that set of videos, and then populate this database. So here we have I'll just very quickly point at a couple of things here. So here we've basically we have a table here listing all the plates. Now plate would be like an agar plate. So in the future we're anticipating that with Andre Brown's new Worm Tracker 3.0 we'll have multiple worms on one plate. So we're allowing for this possibility here with the worm list table here and a worm here. which is associated with a strain. And a plate is also associated with an experimenter, a lab, and a user for user access control. And each plate has a video. So this raw video is then converted by some computer vision algorithm to a wireframe, and then we move down this pipeline here from wireframe to measurements to features to histograms. And it's with these histograms that statistical tests are performed, and it's with these histograms that we have over 700 of them for each worm. And we're in red here. I'm anticipating that we'll have plate features. So these are features not in a one-to-one relationship with the worms, but instead with the plates. So there could be, for example, we could have a feature that might be number of worm interactions per plate, whereas in the past, because there's only one worm on a plate, obviously that wouldn't be a valid feature. It wouldn't be an interesting one because there'd be no interactions. But now we can start looking at things like when worms are interacting with one another. So this is less useful to OpenWorm, the interaction side of things. But well, I guess potentially we could have multiple simulated worms on a plate. But the important thing for OpenWorm here is that at the end of this process we have the potential to calculate a fitness function. So maybe I'll stop there briefly and ask if anyone has any questions at this point.
So it's looking at some of the new stuff here, and I think in the last validation meeting we were talking about getting all the data organized, basically improving on the structure of keeping track of things from .mat files, which were these MATLAB files that were I don't know, a bunch of different details encoded in probably what should have been a database originally, but they just sort of like put together in that way because it was the best that they could come up with. It was expedient. So the idea here is to take this database of movies and take all that metadata and put it into these nice relational form and let us do lots better searches through it, and also to sort of help think broadly beyond just this one corpus that we have, but also future corpuses that could be different, right? That's just
exactly
summary.
Exactly.
Okay.
Yes.
Very good. Cool. So I think one question would just be like, as we're doing that in parallel, I'm just going to be wearing my closing the loop, hat. This is reusing? This is like at least the cloud-based thing is reusing methods that have already been developed that work on the command line, right? That help us pull things out, I think, of map files already, or I guess what I'm wondering is that it seems like we're building version 2.0 here, and I definitely want to know as well what 1.0 was and
right.
how usable it is like right now.
Okay, so let me just go back here to, okay. So this is basically the pipeline here, and so you're talking about closing the loop. So our opportunities for the first half of 2015, I've listed here to complete the analysis pipeline. So just to walk through the steps here, and I've crossed out the ones that we've accomplished. So number one is the corpus of data. So we'd want to host the corpus of data. Number two is to analyze those, or to segment those using a computer vision algorithm. Number three, to normalize that wireframe, to standardize it so the contour has 49 points along the length of the worm, which has been what the Schaefer lab used as their standard, so they could divide it up into anatomical pieces like the head and the mid-body and the tail, which is what the features refer to. So to normalize it, and then to calculate what we call pre-features, like really simple things like the width of the worm along its body. And then it's only at this point that we can start calculating features, histograms, and statistics. So to close the loop, what's missing and what I can't wait to show Matteo the moment we get this done is that we need to develop this in-house. We need to be able to normalize a given wireframe, and we need to be able to calculate the pre-features on that normalized wireframe. And once we can do that, then we've developed this minimal worm specification here, which would be what's given to us from Geppetto, which would be a contour, and you can and at this point Geppetto can give us any number of points along the contour if they want, because we'll be able to normalize it on our side. And then the head position, which we'll need, we would like to have at least, and I think that would be easy to do from the simulation end anyway. And the segmentation status, which is trivial from the simulation end again. Frame code's also trivial. So this is just what we need from Geppetto here. And if we have that, then we can go right ahead into normalization, calculate those pre-features, and then features, histogram statistics, perform statistical tests, and deliver that fitness function back to Geppetto. So you can see here in this list what's remaining to be done, basically, to make that happen. The normalization and the normalized worm pre-features.
Michael, are we...
Steven, you're muted.
Is this including that eigenworm analysis and representation?
Yeah, so eigenworms are one feature. So, well, they're eigen projections, we call them. So that's the feature, and in fact, I can show you. So we have documentation on all of these. Let me go back. So eigen projections is a posture feature. So all of the features calculated right now are adapted from the features the Schaefer lab calculated, and so I basically took the supplemental data from the paper that they published on this and ripped it apart and put some of the diagrams into various places. So that's what this is here. And where eigen projections? Here we go. So if you like, this is where the eigen projections are described, and this is basically the data behind the eigen projections. So, or this is the eigenworms that we're projecting, that we're finding the orthogonal components of, if you will. So, the eigenworms have already been calculated. As it says here, the eigenworms were computed from 15 N2 videos, so the wild-type videos, so roughly 3 hours of videos, and that's what produced this here. So these are the stereotyped worm postures, the 6 worm postures, and so the eigen projections are just projections of these, if you will. And there's some detail here. You can read it. But yeah, so these would be calculated on any worm video that's submitted. So we're always using these stereotype worm postures to calculate the projections.
This is awesome. Okay. This is awesome, and I'm thinking this is really motivating me to want to try and add some of this content into the master OpenWorm docs, because I think the path to some of this stuff, again, I'm just thinking about, like, what does it take to get somebody to actually get to this page? I think first they have to come into the movement validation and then they have to see it, but this content is rich, and I think it could bring people into the project seeing how much is there already. So that's a task for me, but there is a way to turn, I know, I've seen that there is a way to turn just straight up Markdown into read the docs type material, not go through RST. I think it's rather new, but I might try to do that.
Well, it's funny you say that, because in terms of documentation, we've had an issue outstanding for quite some time to get the movement validation documentation working in Sphinx, and so we've had a couple of volunteers actually that were super interested in that. So we had a guy called Randy Nguyen who I spoke with and was interested in this, but the guy who's submitted a couple of commits on this is Phil, and Phil E, whose last name I can't say right because I don't remember his last name. Yes, that's the guy. So he's been great. So we had a couple of issues out, and he just basically did them and submitted a pull request. So fantastic guy, and one of them is converting all our Markdown into RST. And so maybe you're saying that is a moot point because we don't need to do that. But one way or the other, we definitely have movement afoot on our end to get everything working in a Sphinx type setting.
By the way, this raises a point because I've noticed that particular pull request. Have you had a chance to merge that?
No.
Okay. This is something for everybody as well, and I'm bad at it. Okay, so it is easy to let pull requests kind of go unattended for a while, and I am the worst culprit of it. Okay, so I'm saying this for me, but for all of us. But pull requests are like the most pure demonstration of a contribution to the project that we are ever going to get. Okay, like a question or a comment is way less pure than somebody who's actually written a pull request, which means that they've like done stuff, right? So it is also, GitHub does not make it very easy to see the pull request because it just looks like another issue or a comment on an issue. But there is a specific link that you can go to see all pull requests that you have, that you should be notified about and do something about. And I'm going to dig it out and share it with you because I also just can't type it in. But let me just use this as a way to say, like, let's try as much as possible to jump on pull requests because somebody who's taken the time out to do something and then doesn't hear back and it just sits there, right, obviously is going to get disincentivized. So
Agreed.
I think Stephen,
on you, but like I said, there's like 10 or 12 of them that I have failed, that have gone weeks, and I haven't gotten back, and literally because I didn't see them, and I go back and I feel horrible because somebody's done some work and then I haven't like gotten back to them. But
I was reading this is actually what prompted the whole development of Git in the first place with Linus Torvalds, is that he used to do it just by manually patching things himself before they even used Bitkeeper, and he would take months and months to add people's work into the kernel, and so people got really frustrated with him because of that, and so they finally needed an actual version control system anyway.
Exactly.
Yeah, the way that I do it in Geppetto is that basically I use a process whereby before each release, which is once a month, I make sure that all pull requests that were opened in the past month are taken care of. So either merged or closed. Usually it's merged. I never close any, but it's like it just forces me to have a deadline by which I regularly have to review everything that is there. Some things I'm more aware of them, and I might merge them right away when they happen, because maybe I was expecting, etc., etc. But at the very least, once a month, everything goes in.
Okay.
Right.
That's a good process. So here, at this link, which is github.com/pulls, you can get an integrated view across any pull request that's come into your wheelhouse. So you might just take a chance and have a look at these and see if there's any outstanding. I have some that are outstanding, but the ones that for me now, as far as I know, that are outstanding, I'm having active conversation with a particular contributor about how to improve it before merging. But yeah. Okay, thank you. Sorry, but that was, I just needed to, it's a good practice of open science community, and I need to add that to the community docs as well, so talk about that. But okay. So what I wanted to ask as well, Michael, is so you've got this list, that roadmap, and there's a bunch of like awesome tracking things, and you do the big picture really well. What I struggle with sometimes is to find like the latest issue that is on like one of those things, like you said. So like normalizing, or just in that list, like can you map that to issues, or just show me which ones they are?
I cannot at this exact second, but I totally agree with you that it's on my list for a while, and now that I've developed this roadmap, I think it's pretty clear that I just need to align every single issue that we currently have open into that format, because I think that what I have is what's on the plate for the next 6 months is basically everything to finish the ultimate vision. So if all that could be worked into a set of milestones that are clearly outlined with issues attached, then that would be ideal. So I will work on that right away.
Okay, and just to just to not put a ton on your plate, like you could do this iteratively and just start with just the things that are the most critical, like those two that were in the middle there. Those two steps, you don't have the doc up anymore, but those two steps that you're like, if we do these two things, then we're getting to closing the loop. If you can just start with like an issue per one of those, you don't have to flesh out the entire roadmap, but it's at least enough. And the reason I ask for that is because like the next person who says that they want to do movement validation, would be awesome to literally, it seems to help retention when I can point them at a specific issue, in addition to connecting them to you, and I can say, this is something specifically like to work on.
Yep.
So just I know it's a thing, and it's great to have it awesome and perfect, but let's better just to have something that's iterative than to do the massive thing. So, but okay. Other questions about this? Other questions?
Okay, well, yeah, that's movement validation basically in a nutshell. So,
okay.
Thank you very much.
Okay, awesome. Thank you for that. So, so you showed us some code. That was a good precedent. We're going to keep building on this and improving on this process as well. But so next up, we'll have Poreg next time. Try to get into some of the the practical and where things are. And I think this already led to some good interaction. So thank you, Michael, for that.
Yeah, just one thing, Michael, just as a reminder, I think that the way to move the intersection with Geppetto, the best way to do that is eventually to have a meeting. So just feel free to like schedule one so that we can do that, because it's definitely interesting, but we need to look at the details of what we need to do all of that, because at the moment you know that the biggest focus in Geppetto has been like the simulation aspect, regardless of what model, regardless of what simulator you're using, etc., etc. Now you're getting into a territory that I would love to go to, so that's why I like to talk. But it's more in terms of analysis, like give an input, take an output out of Geppetto, and so that's something that requires thinking. And I think there's also interesting intersections in the high level, in the starting point that you have for like the definition of an experiment, the definition of hypothesis of why you're doing an experiment to begin with, things like that. That would be very interesting. And then having the movement validation as being one instance of that, because I think there is a lot of stuff that is in common to multiple things. It's like it might be when you are recording new data that you're making some hypotheses, you're recording new data, and then you will look at the data, you will analyze them and see if they confirm whatever hypothesis you had. In one case, you are taking a video of the worm. In the other case, you are doing patch clamping. Obviously, you're not doing patch clamping with a worm, but the idea is the same. So I would like if Geppetto could help in bringing all of these things together wherever there is a common thread, so that then we can also bring together all the mappings to computational models, because at the end of the day, then you have things like cybernetics that, for instance, predicts what the experiments were showing, and then you can compare them, which is what you want to do. So bringing all of that together, I think it will be very interesting, but it's obviously a big endeavor that will require starting to talk about it.
Sure, yeah, no, I'll reach out to you, we'll do a meeting.
Sweet.
Thanks.
Cool. Thanks.
All right, so let's go round robin and talk about updates. I'll kick one off just to get it in real quick about PyOpenWorm. So I've been, and then I'll also talk about the server real quick. So PyOpenWorm, still been working. So Matt Watts, the Google Summer of Code student, has come back and has continued to contribute. Also, a gentleman named Travis Jacobs has been doing a lot of great contributions. Another guy named Anton Chekhov has a pull request in. We're just about to close. Has also been very helpful. And also some of the other folks that have been going back and forth between muscle modeling and PyOpenWorm, Ari Richman and Abdullah Rashid, have all been kind of getting into the act over there. We're basically porting the connectome, the information about the connectome, from a spreadsheet that we had, which when we compared it with what's on Worm Atlas looked like there were some confusing mismatches. We're going back to the most authoritative thing, which is essentially the website that is on Worm Atlas. We're building that into PyOpenWorm, and we are down to the last handful of issues finally with the alpha version, so that we can get to master. And the conversation is ongoing. in the Gitter channel for PyOpenWorm, and literally I just this last weekend I was in there again retesting it. Features that were not working before are now working, so you can get the type out of a neuron. It's like a very basic thing, but that's now working. So I know that this has been a long time in coming, but all I can say is that you know, it needs to be at least minimally functional before it goes out. We're not over perfecting the thing. It's just like if you ask for all interneurons and you don't get anything, that's like not going to work. So so it's getting much closer to release, and with that, hopefully, we'll come looking back at how to reintegrate it with C302, so that instead of being from the spreadsheet, it's being driven off of this. I just want to show everybody that although it hasn't happened yet, it is still happening, and now it's better because there's like 3 or 4 people that are really taking, you know, really driving it more than me, which is good because God help us if I'm the only one who's gonna make it happen. So so that's moving forward. And then with the database, the hard drives and the server, I just posted, you know, while Michael was talking real quick, what's going on with the hard drives. You know, please forgive me for not having done it sooner. But basically, we've run into a bit of a problem. I think in shipping, the OS of the NAS got corrupted. This is my current theory. So after not having the password to log into this box, then getting the password, then actually logging into it, the Linux on this set of hard drives basically said, I can't log in, basically. So there's some error messages, and I posted them on the issue that's running on that just now. But basically, I have to create a boot USB, Linux boot USB, to log into this thing so that I can even pull some files out. And Balash has been hungrily waiting just please give me like 6 files. And I'm like, I'd love to, but I can't actually log into this thing. So just last night, I downloaded Ubuntu, and I'm putting this thing on a gigabyte USB, and so hopefully I'll be able to log into it when I can next iterate on this. But apologies for the slowness on that. I am still working on it. It's still important to me. It's still important that it gets out there. I don't want anybody to think it's not important to me. But my bandwidth for doing all these things and getting PyOpenWorm out and Muscle Model and journal clubs and all that is not 100%. So.
Do you want to mail the hard drive to somebody else if it's super difficult for you to find the time? I mean, that's an option out there. I'll just throw that out there.
At this point, I've invested enough time into it. Plus, the shipping didn't seem to help. Honestly, is kind of what I'm thinking. I literally think like being jostled or something is why this is happening. So I'm not sure if it's even a good idea for it. But yeah, I don't know. I basically when I couldn't log in, I was like, and then it kind of took me a week to get back to caring. And then
my sympathies. Question, Stephen. What is the capacity of the hard drive? Is it listed physically on the outside of it? I just want to know what the upper bound on how many videos I'm going to have to pay to host on the S3 on Amazon.
Yeah, I saw the thing about S3, and we should open that as a different conversation. But my understanding is that it will be cost prohibitive to put it up on S3, so you might want to recheck that because it is approximately, the capacity is 5 terabytes.
5. Thank you.
5 terabytes. So you can cost that out, and I've done it too. And it's still, although storage is cheap, it's still not that cheap, unfortunately.
Agreed.
If you find
we can talk about that later. Yeah.
Okay. But I'm still working to put it up, and I'm trying to update you folks on steps and be transparent. Okay. So, can we go to Matteo?
We can.
Thank you.
So. All right, I was trying to update the agenda, so I linked to the agenda the last agenda of the Geppetto meeting that happened last Tuesday. Some high-level stuff, and I wrote on the agenda some of the details of what the individual peoples are working on. But in general, we're now at the sprint 43. Let me start sharing my screen. Basically, there is one thing that we started using are story points, and it might be because they were implemented only recently by Waffle. Oh. So I don't know if you guys noticed, but this is something very useful because it means that not all the cards are the same. We know that some things take 30 minutes, some things take 30 months. So now we're starting to have numbers on the different things, and every time I see one that doesn't have it, I try to at least put my ballpark estimate for that. So yeah, there are things that are happening. These
just real quick, the idea of a story point is
the idea of a story point is a way that, regardless of what convention you use, it basically determines the size of a task. So in Geppetto, I'm using the so that everyone is on the same page. One story point equals 1 hour. So if it is 5 story points, it's 5 hours of work. And of course, they have to make sense to whoever the card is assigned to, because it's like 1 hour of someone might be different than an hour for someone else. So, but as long as the person that the card is assigned to is comfortable with that, then that's the metric that we are using at the moment. So in terms of milestone, this is the stuff that is happening in these just 2 weeks that have passed. Like, there's a lot going on there, and I will be releasing a new version 0.2.1. But since there is a Geppetto meeting that just goes through this stuff, what I wanted to stick to in this meeting was the parts that were more interesting for specific application for OpenWorm, rather than the technology behind it. I mean, there's a meeting for the technology. So, and one thing that I think it's very useful is that now we do have, which is what I wanted to show. We do have, after a good couple of things happened, support for the C302 social circuit that was that had been in GitHub for quite a while, and it's nice and useful for many reasons. So it is a subset of the whole C302, so you can explore a specific circuit and you can look at these specific neurons. You can even simulate it using JLens as it is happening here. So now I had this ready. So and this is just coming from live.geppetto.org, so it's not running on my machine or anything. Basically, eventually, we'll see the signals start rising. What we're plotting there is the membrane potential for all of the neurons that are in okay. What we're plotting is the membrane potential for each one of the neurons, and it's like this is what we're looking at. There is still a few things to fix, in the sense that it is difficult to work with the 3D visualization, because centering is not working. As you load these, they are just off the screen, and then there is another issue, which is about like, you can see the different colors for the inputs and the output, as we know we do, but the connection lines are here, okay, while they should be attached to the neuron. So that's another card that is there, that we know it's happening with these models, and actually made some progress over the weekend to find out why that is happening. But we couldn't even load this just a month ago. So this was definitely good progress and interesting. What things are interesting? The things that are interesting are that we can explore the model from the interface as well. So we can see for instance, these are all the cells that exist in this circuit here that we see, ASHR, ASKR, blah, blah, blah. We can expand each one of them. We can see to what they are connected to, okay? So you can see what are the synapses that exist in each one of these connections, and this is how they've been characterized by Oreg, I believe, who was the creator of the model. And we can look at the model itself. So with the different parameters, we know that this is a integrate and fire model. So those are the parameters that we find here, and then other things that are possible beside simulating, looking at it. We can, since last month, we can also look at the connectivity metrics for this, which is just another widget, and here we see in different colors the different synapses that exist in this subnetwork. And yeah, and basically all these things are making the exploration of the model actually useful, and we're doing all of this from the web. All of this stuff is in like constant development. And hello, Boris. There is one of the Geppetto contributors that has actually worked on the connectivity, which I was showing. It was,
Boris, your stuff is famous.
Yes, Boris is very famous. And so this is something that for release 0.2.1 of Geppetto I want to add as a sample, so that it can be easily accessed from the menu here. And the sample will have all these widgets already configured, so that the user can just bring them up. And every time that somebody comes in and say, hey, what does I have no idea, because I never worked with anything remotely related to computational neuroscience. In what world, in what universe am I? Instead of saying, well, take those instructions there and spend like an hour and a half trying to setting up your local environment. And you know, depending on what your platform is, it might take more or less time. It's like, go to this URL, look at that, and that's the universe in a snapshot for you. And I think that this has been the goal of Geppetto as a technology project to make the science usable and accessible by everyone. So supporting science and serving users that don't necessarily enjoy spending a lot of time installing stuff, but might be very well interested in actually working with the models themselves. So, and this would be an entry point. And obviously, once people get hardcore, then they can do they can get into doing all the kind of setups they want, etc., etc. But this is, at the very least, right now, it's serving the purpose of being a very inviting showcase that you can do some basic things with, like looking at the stuff and looking at the geometries and doing basic simulations. And this is where we're going. And I suppose that in this brief demo that I gave here, I'm summarizing what is the current status of Geppetto.
Perfect.
Quick question, Matteo. Is that C302 social A or B?
A.
Okay, I should probably put that into the name to emphasize that it doesn't actually have gap junctions. It just has chemical synapses for gap junctions in that version. But B should work now, and that one has gap junctions.
Yeah, we can add a pop-up widget to.
I'd even go so far as to rename it, because you have just lem/c302 social/geppetto.xml, just to avoid confusion down the line, because we want maybe B in there as well, and C and D.
Oh yeah. We can. I can rename the thing.
Okay. All right, guys. So we got about 8 minutes here. I do want to try to get us out on time, or it looks like we may go slightly over. But so let's just try and do the last updates real quick. So Andre, haven't heard from you in a little while. How are you?
Well, thanks. I'm fine. I continue my work on simulation of nervous system of C. elegans. At previous week, we had a good conversation with Podrick about all this. We have discussed well, my view of this problem and some questions with which I'm trying to work also discussed C302 project and approaches used there. Tried to find some common points, kind of ways of collaboration in this field. Also, I tried. Also, we have discussed that it might be quite useful for me to try to install C302 at my machine and try to use somehow this technology, because it's time for me to use some data about morphology of neurons and connection between them, and it will be much better to do it automatically, not manually by entering all points and these 3D coordinates by hand. So I'm doing some steps towards these goals in this direction, and I think everything is going quite successfully. That's it.
And I still owe you a meeting on the paper. I saw that you submitted again. The Journal of Computational Science. Is that right?
Right. And by the way, I have good news from there.
Oh yeah.
So I have submitted that paper, and yesterday its status changed to under review.
Under review.
Yes. This means that editor decided that the text is good enough to send it to reviewers.
Fifth time's a charm.
So it was not.
Still hasn't been reviewed at all. It's just.
It was not pushed to trash box as usual.
It's like, this is not relevant.
They decided to consider it somehow.
Great. That's great.
Well, I think we should expect some news from them maybe within a month. This time is usually necessary for reviewers to do their work.
Good. Cybernetic needs a publication. And then we need to put out the actual OpenWorm part of it next. Oh, okay, good. So we should try to meet in the next couple weeks to chat about next steps on paper.
Yeah, that's right.
Okay. All right, great. All right, 4 minutes left. Let's go to Porig.
Okay, very quick update. I've been doing a lot of work with, just practical work with the C302 and some of the muscle cell model, making sure that it ran in Neuron. So the muscle model, as it has been there for a while, actually what I've also done is just double-checked the numbers being used in that model against the Boyle & Cohen original MATLAB version, and I'm quite confident on most of the values there, and I believe some of the others who've looked at it have checked through and saw that they match quite well. So the muscle model now will work if you export from JNeuronL to Neuron, which is a good sign. I've also done some work on getting gap junctions working in, they had been working in LEMS and NeuronL. They're now working a NeuronL file using gap junctions that can be exported to Neuron. Both of these are pretty essential for getting the full worm model fully mapped into NeuronL2 and then getting that into Neuron, running in Neuron. As part of this as well, I've been cleaning up the C. elegans NeuronL neuroconstruct project, so I've made a few changes there just to make sure all the files are up to date, because those haven't been updated in a year or two actually. So a lot of these will be updated there. I'll also retest some of these with Geppetto, and I've found some things are a bit slower on the current version of Geppetto, so I'll be opening some bugs for that. I've already mentioned some of it to Matteo. But all of this work is basically towards getting the good framework in C302 to be able to incorporate the ion channels, be able to incorporate multi-compartmental models, and be able to scale up to these detailed cell models with gap junctions, eventually with analog synapses as well, and get all this running either generally as the target in Neuron, but have it fully expressed in NeuronL2 valid files, and then get all the behavior of this simulated in Neuron, and eventually link it back to cybernetic for linking to the behavior. So that's ongoing, and yeah, I know that there's a number of issues outstanding as well that some of the guys working with the muscle model, I need to get back onto those hopefully by this week. But yeah, there's work happening on this, but the code is in much better shape than it was a week or two ago.
Awesome.
And that's all for me.
We're generating good positive feedback loops with everybody. It seems like we're generating more and more good stuff, and that community is doing really well. So, okay, and okay, Michael's got to go. All right, 1 minute remaining. Tom, what's new?
Short status. Kind of trying to stay ready to jump into the muscle model thing. Haven't had a lot of time. Been reading the papers, keeping my tools, so in working order. Like I said, I did submit the genetic algorithm paper to neurocomputing. Got to revise and resubmit, so I did that.
Okay.
And then I also, a little bit ago tried to port. Well, I did port cybernetic to the supercomputer that I've been working on, and so it runs, but it doesn't quite use all the cores that I was hoping it would use to get some measurements. So, kind of put that away for now. So that's my status.
Okay, awesome. And with regards to, if you're still, working with the genetic algorithm stuff, there's a resurgence of that stuff that's coming about with regards to starting back to the ion channels and getting the right parameters per ion channel to match IV curves and then building it up to the cell level. So the work around Pi NeuroTune, there's this issue, maybe I should also mention you on that one, but this one where instead of using optimal neuron, they're switching to Pi NeuroTune and Pi Electro, and Org has a nice example, nice listing of what folks could try. I'm sure there's folks that are coming in still on the optimization theme that I'm pointing in that direction, and that might be another thing when you get some time to maybe, because again, I think the algorithm that you use, the fact that you could apply it, the fact that you could close the loop, the fact that you could make results, I think is a pattern that we want to reuse at these different scales, not just at behavior, but at single cell and ion channel level. So maybe there's something there as well.
Yeah.
Cool. Okay, 10:01. We all got to go. Thank you, everybody. I think this was awesome. Did folks like the deeper dive thing today? Was that helpful? Was that good? See a nod? Yeah?
Yeah.
Okay. All right, cool. So Porygon for next time. It'll be in 4 weeks, 3 weeks, 4 weeks, whatever it is. And till then, I'll see you guys all online through our other various media. Thank you very much.
Okay. Bye, everyone.
Bye-bye.
Bye.